welcome to everybody. Good morning, good evening, good afternoon, depending on where you are around the world. Obviously, Ansys and all their channel partners have put a lot of effort into the second annual Simulation World Virtual Conference. I'm not going to spend time here during this session, outlining why Ansys or the features and functions and capabilities, of Ansys and why it's best in class. I mean, there's plenty of those sessions that I'm sure many of you have already attended and will continue to attend throughout the conference here. So really, I wanted to focus this session today more so on, why simulation in general, and even more importantly, what to look for when choosing an Ansys partner to not only purchase the software from. You can do that with anybody, but what to look for in a partner to make sure you're getting the most value add from an implementation and ROI standpoint. So like any sort of presentation, if you will, quick introduction to myself here. My name is Jason Pfeiffer. I'm the Vice President of the RAND Simulation Business Unit here at RAND Corporate. We'll get into the overview of kind of how RAND simulation has come to exist here in a couple minutes, but just a quick couple highlights of my career. I'm a degreed mechanical engineer, went to Virginia Commonwealth University in Richmond, Virginia. I'm physically located in Charlottesville, Virginia, here in the Mid-Atlantic area of the United States. I worked for Altair Engineer, another decent-sized player in the simulation space, a little more than 20 years ago as a consultant. Using LS Dyna, we actually simulated Dale Earnhardt's fatal crash. For those NASCAR fans and audience here now, a lot of the car tomorrow came from those efforts. And that's actually where I got my love for, using simulation as a consultant as part of a business model as well, which we'll also talk about shortly. I was a global VP of engineering at another CFD specific company called CF Design, or Blue Ridge Numerics. CF Design was the product name. Long story short, we sold that to Autodesk about 10 years ago, almost to the day. And then after that, I had my own, small, CFD and FEA consulting business, and later sold that to RAND Corporate, and have been driving a consulting and RAND business, Ansys business unit, over the last few years here under the RAND umbrella. So that's a little bit about me personally, but more importantly, what are we going to cover during our session here today? Kind of back to elementary school, who, what, when, where, why, and how, right? So some of those, who is RAND simulation? We'll cover that. Why simulation-based design? Again, you're learning a ton about, why the Ansys technology specifically, but why even simulation? Why should you take more of a simulation-based design approach versus just historical product knowledge or, just doing physical testing, all that sort of stuff. And then also, really the brunt of what I want to share with you today, at least my thoughts on it, is what specifically to look for in an Ansys partner and how we're successfully partnering with folks and collaborating to help them get the most value out of our partnership, whether that be on the consulting side and or the services side, because many times they go hand in hand. And then listen, we're not all things to all people, but if throughout the course of this or when we're done, it's virtual, so unfortunately we can't have a Q&A session, but if what I'm outlining and sharing seems to resonate and, you'd like to learn a bit more about us and kind of have a mutual discovery to figure out if it would make sense to potentially partner with your organization, I'll outline how best to contact us in a quick, efficient manner. So let's go ahead and get into it. One of the things I wanted to talk about, just to kind of set the stage, when you're looking at a partner, obviously you want to make sure it's a partner that's been in not just the simulation world, but the product design world for many, many years, if not many decades. So I at least wanted you to see how the RAND simulation business unit, or what is RAND simulation today, really how that came to be, how we've evolved. So long before RAND simulation, as I said earlier, I ran the global engineering team at a company called Blue Ridge Numerics. We were the ones that actually created this whole sort of upfront simulation market. Those that have learned a lot about the Ansys Discovery platform, which is a phenomenal tool with, ease of use, real-time results, phenomenal graphics, et cetera. We started that, that industry, if you will, and that mantra. And what we did in 20 years at Blue Ridge, Ansys has done in literally, 2 or 3 years, and did a lot more than we ever did, which I think is a testament to the R&D power at Ansys being exclusively a simulation developer there. So anyway, we sold out to Autodesk. What's now the Autodesk CFD tool used to be CF Design. Candidly, I did not want to go to Autodesk for a variety of reasons, nothing against them, but I wanted to follow my passions after starting a consulting arm at the Blue Ridge business and be a consultant. And I created a little company called Informative Design Partners, took some of the sales and technical leadership with me, and we had a heck of a lot of fun. We had no intentions of selling it, but started having conversations with the C-levels at RAND Corporation, and we decided to partner with them. So I sold that business. Imagine it really is kind of the big business unit under RAND Corporate. It's really the world's largest reseller of Autodesk solutions. So we were put under that umbrella to provide specifically, consulting simulation services. Ansys rather started courting me back in 2018 saying, hey, we're really looking to grow our strategic channel network in North America. Obviously, Jason, you and your team have been in the simulation world for many, many years and decades. What do you think about, becoming a partner? So I figured, hey, if I'm going to get back into the world of software sales, not just, simulation consulting, might as well do it with best-in-class Ansys. So it was a pretty easy decision for me. So for the last 3 years, we really have been, providing Ansys solutions to customers, and providing consulting with Ansys software when that makes sense. And we'll get more into our background, which I think is important in choosing a partner here in a bit. But, fundamentally and at a macro level, literally with the number of team members we have, which, by the way, we have about 30 people these days between primarily sales and engineering. Of course, we have marketing efforts and, back office finance, et cetera. But we have about 30 total between sales and engineering. And with that collective team, we've really been at this for well over 250 plus years. Again, not just in the simulation space, but in the design space. So we really know where simulation fits, how to apply it in the development process, et cetera, et cetera. Having very strong consulting backgrounds, we literally have conducted no less than 3,000 projects in the worlds of CFD, computational fluid dynamics, think fluid flow, heat transfer, things like that. FEA, structural analysis, and quite a few electromagnetics projects as well, from signal integrity, passing current through PCB boards, mean time between failures, et cetera, et cetera. And then lastly, being both and as a consultant and a software provider, not just with Ansys but other OEMs over the past few decades, we've also implemented at least 2,500 instances of engineering simulation solutions into our customers' product development process. So fundamentally, as I said earlier, there's two facets or components, if you will, to the RAND simulation business. One, like many others, we are a strategic reseller for North America, which means we can sell, the entire portfolio, which you see here on the right, all the different tools that Ansys offers, which are quite many. Frankly, it could be a challenge to make sure we have the technical aptitude and expertise in each one of those. But we provide, all of those as software solutions when it makes sense. But quite frankly, sometimes for a variety of reasons, it makes more sense, especially in the beginning, maybe to start, by having us, kind of be that Green Beret team and come in and solve the challenging problem that you have more as a consultant. And then that kind of builds the value case and business proposition to buy the software. And frankly, that then gives us something tangible to train you around to come up to speed quickly on Ansys and flatten that learning curve. So again, Ansys reseller, and we also use the best-in-class Ansys tools as a collaborative consultant when that makes more sense. So it's really nice in that, it's not one or the other. We have the right solution for each customer's specific situation. So before we talk about, which situation may or may not be right for you, candidly, that's why we should probably have a call after this if what we're talking about and sharing, kind of strikes a nerve and you want to have that conversation. But before we get into that, let's just talk about why simulation in general, right? Whether it's Ansys or, SolidWorks or, Siemens these days, there's no shortage of software OEMs that offer simulation solutions. Now, Ansys, I think one of the reasons personally they're best in class is this is all they do. All of their R&D goes into just simulation tools, not simulation plus CAD plus data management and PLM. It's just simulation. But outside of that, why are people starting to lean more towards a simulation-based design approach, whether that's partnering with a consultant like us or purchasing the software and getting support from a value-added reseller like us. Fundamentally, what I've learned over the past few decades is, the typical new product development goals really are always the same, right? I mean, you're trying to improve your design, get stronger innovation, make sure it's, you have the right competitive differentiation. You want to use, you want to be able to market, not just verbally and put pretty pictures, physical static images, but you want to show simulation results and differentiate across the competition. You want to, reduce physical testing. You want to compress the time to market, minimize production costs, so on and so forth. So there's a process component to the business, that simulation caters to as well. So, I mean, ultimately, all companies out there want to compress development cycles and introduce more innovative design solutions that do one of two things, either address a new market need or improve upon existing technologies, all, of course, while minimizing design and production costs for stronger corporate profitability and shareholder value. So even though that's consistent with just about every company out there doing product design these days, the strategies they use to capitalize on those new product development goals vary tremendously. Obviously, I'm not going to go through every bullet point there on this image on the right, but ultimately, in my opinion, there's three ways you can go about those strategies. Whether it's individual or you combine all three, which I think you'll find is what a lot of people are migrating to these days. Of course, you can just leverage historical product knowledge. Hey, you've done it a long time, right? If it ain't broke, don't fix it. Why reinvent the wheel, sort of thing. So you can just leverage exclusively what you've learned in the past. You can do physical testing, which, quite frankly, I would always advocate. Even with simulation, you always do at the end. There's nothing better than actual physical test results. Simulation is there really to give you insight, to drive informed design decisions. And of course, naturally, simulation, as I just stated, is the third component of that. So to me, until you combine all three of those, do you have, the ability to make the informed design decisions, use physical testing, which again, I always advocate, but use it one time for physical validation instead of that manual, exploration process, faster optimization, confidence in the design. Again, you can read all of those bullet points there. And once again, this is why we provide Ansys both as a software solution when it makes sense to your organization, as well as a consulting arm when that might make more sense to the business. And every situation is different. So frankly, another reason we offer both the consulting services and the software component of our business is to effectively handle the time to market goal that all these organizations have, right? But what I've found, and what many of our customers tell us as well, is that, there are a lot of hidden barriers, time barriers in a new product development process. This is a busy slide. There's actually a video on our website that's, 3.5 minutes or so that'll walk you through the entire narrative around this. So I apologize for it being busy, but ultimately what this is trying to convey and educate you around is the 5 hidden barriers that most people either aren't fully cognizant of, or they haven't really sat back to quantify how much of a delay in time to market is occurring because of how much time they're actually sinking into each one of these sort of roadblocks, as I'm calling them. One is once you kick off a design, process, you've met with, sales, marketing, engineering, you get hey, this is our go-to-market strategy, this is what we want the design to do, et cetera. Normally it's not just a mechanical team that goes and does the design. You might have an electronics component. You might have, a structural aspect to it, fluids, heat transfer. So there's a lot of time just pulling multiple different disciplines together. Once you actually pull those together, have a starting point design, you got to start somewhere. Ultimately, you want to build it and test it, right? But many times, you'll hear, hey, it might take 6 weeks. That's a long lead time part. So you're kind of dead in the water for 6 weeks, waiting for, materials to arrive or waiting for the machine shop to free up to actually build the components. Ultimately, once you test it, only to find out that it failed. So then you have to figure out, well, why did it fail? You know what I mean? And figure that out without seeing the invisible. That's what simulation sort of brings to the equation, so to speak. And then you get into this sort of, iterative loop where you do that over and over and over again until eventually many companies decide, you know what, we can't get to the ideal solution we were looking for that we decided we wanted in this meeting over here, so we're going to have to make some concessions. Well, you can't go into the VP of engineering, the VP of marketing, the VP of sales, maybe the CEO of the organization and say, hey, we have to make concessions without having tangible proof as to why, right? So again, that's one area where simulation really adds a lot of value, but there's a lot of time preparing for that stakeholder meeting, ultimately to come to some consensus on what concessions you're going to make, redesign it, and then, ultimately launch the product. Only to find out, even though it passed internally, hey, maybe one of the customers that bought that product or widget from you was using it in a capacity that you ultimately didn't test for, and it's failing. And now you have to start this entire process all over again. So again, when you look at these 5 hidden barriers that people, again, either aren't aware of or typically haven't spent the time to quantify, all the more reason to start seeing why people are leaning more towards a simulation-based design approach to address these barriers, have more confidence in design solutions, and get better products to market faster that don't ultimately fail, but actually allow you to capitalize on the sales and profitability goals that you have for the organization. All that to say, right, that it's important, whether through a consulting partnership or your value-added reseller of Ansys, that you partner with somebody that's been doing this a long time, has been around the block, knows the theory behind simulation, but also, and this is really key to my organization, making sure that they don't just know Ansys, but have been practicing design engineers for many years in industry, because otherwise it becomes too academic, and I mean, that's important to understand the theory and this and that, but I want people to know how and where to apply this in the product design process and be able to guide a new organization to simulation through that process quickly and efficiently. So again, not to tout our team too much, but I do think when you're trying to choose who to partner with, it's important to know backgrounds. I mean, I could talk for weeks about our background, so I'm trying to summarize it, in one view here. But I mean, if you just look at some of the institutions, that many of our engineers have gotten degrees from. And quite frankly, I would say about 50% of the engineers on my team are degreed PhDs. Everybody else has a minimum of a master's degree. And these are coming from top-notch, engineering organizations. I won't go through all of them, but whether it's, Purdue, Ohio State, Pitt, Columbia University. I mean, these are big, very well-known globally engineering institutions, and that's where they've gotten their degree to kind of give them that strong foundation. But then if you just look at some of the logos below, these are actual industries and companies, rather, within these industries that my engineers have worked with and used Ansys at these organizations. And you can tell it spans a lot of different industries there, but more than anything, independent of industry, it covers all of the core applications, whether it's the manufacturing space or automotive, there is a ton of, CFD, fluid flow, heat transfer applications across all industries. Every single one of these companies they've worked for, there were CFD type applications. Every single one of these companies, there were, structural analysis applications. Every company, there were electromagnetic and electronics type applications. So they have many years of applying, design practices and simulation in those practices in real world organizations, which I think is extremely important and paramount when you're looking to partner with somebody to help you come up to speed quickly, because nobody buys a piece of software and says, oh, I have 6 months to learn it. You're already 6 months too late. So you need somebody that's going to help you very, very quickly. And obviously, when you partner with somebody that has done that, numerous times in the past, they're going to be very efficient in helping you achieve that objective. On the consulting side, we have what we call a collaborative consulting business model. Again, on our website, just ransim.com, there's also a video kind of outlining this collaborative consulting process. So I'll do the best I can here in a minute or two, just kind of describing what that is. But fundamentally, as the name implies, it's very collaborative. We believe in some situations, where there's not enough ongoing product development activity on an annual basis to own the software and make it a core competency. In that scenario, we believe, hey, leave the simulation process to the simulation experts, us, and the design process to the design experts, you all. And there's unique roles and responsibilities. From the analysis standpoint, we're there to make sure CAD is properly set up and idealized for simulation. We know what physics to apply and the boundary conditions. One of the key things you'll really want to look for when you're choosing a partner is not just how to get results. A, are they the right results? But B, even when they're the right results, how you interpret those results. Are you interpreting it correctly? Because you can really be getting yourself in a lot of trouble if you're getting the right results on the computer screen, but you don't know how to interpret those to make the right design decisions. So that's really, really important in both scenarios. So really, we see ourselves as an extension of your design team to give you the performance insight and give you a lot of design guidance that fits within the constraints you have for size, cost, design for manufacturability, et cetera, et cetera. And you all are bringing a lot of historical product knowledge, understanding of your manufacturing processes, any goals and constraints you have around cost, aesthetics, et cetera. So we really work hand in hand to quickly converge on the right design strategy. Something else that our customers really, really prefer is, they're used to that consulting, price per hour model. And I learned a long time ago, economic drivers were in stark contrast in doing that. Of course, the consultant, when it's charged by the hour, is motivated to, slow it down to get more revenue. And of course, the customer wants the right answer as quickly as possible. So again, in stark contrast. So many, many years ago, I implemented a fixed fee pricing model, which folks really, really appreciate. And it really eliminates the scope creep, because the reality is every single project has scope creep. No matter how hard you try to dot every I, cross every T, and nail down that SOW, statement of work, there's always scope creep. But if we agree to, hey, this is how much time we're going to allocate, maybe it's 1 month, maybe it's 3 months, we're going to be an extension of your team, you're guaranteed, that solution, and you're paying for the solution and not the hour. So we're really focusing on solving the problem, not ours, and that way we're sharing the mutual risk. If we meet your objectives ahead of the schedule, great, we do better off from a margin standpoint. But we keep going until you're assured that solution. So again, we're really sharing the risk reward there. I'm not going to show any fancy, Ansys simulation images. You've probably seen a million of those already throughout the conference thus far, but I at least wanted you to see some of the core areas where we have a lot of expertise, both as consultants and also in implementing Ansys engineering solutions. And believe it or not, a lot of those are in facility designs. A lot of people don't think about facility design as a CFD application, but if you think about it, whether it's a manufacturing facility, a parking garage, airplane hangars, you can see all the pictures there in different scenarios, but there's a lot of concerns around thermal crosstalk, say in an atrium. Maybe each one of these floors has its own heating and cooling. Well, what happens? Are they communicating? How do you keep the big atrium cool? Are you wasting heat with that hot air rising? There's big concerns with, humidity control and, air uniformity in storage warehouses for obvious reasons. Thermal comfort, thermal stratification, pressure gradients. In a fire event, should the room be positively pressured, negatively pressured for the smoke to go, et cetera, for when people are evacuating, lab spaces, what happens in a chemical spill based on where you have your supplies and returns, all this sort of stuff. So this is an area where we work a lot with MEP, mechanical, electrical, plumbing firms, to help them come up with appropriate design decisions. And many times, frankly, they can share that cost, push that cost through to their end customer to make sure energy efficiency is where it needs to be. Obviously, electronics is everywhere, not just from a thermal standpoint and where to put fans and, hey, is natural convection going to work and what type of materials, but really getting into some of the more, electromagnetic aspects and think 5G and Internet of Things and, just signal propagation and, how effective is the signal going from the transmitter to receiver, how much crosstalk do I have, all those sorts of things, which are great applications for Ansys HFSS, SI Wave, and different tools like that. And then this is a very generic sort of all-encompassing catch-all bucket, but, flow control. My goodness, you look around, your room even, and there's probably, well, maybe not in your room, you'd see electronics in your room, but you drive down the road, there's no shortage of applications that are controlling flow in some capacity. So yes, naturally, valves and filters, things where, you're trying to minimize pressure drop, you're trying to get flow uniformity, for various reasons. Maybe it's in a dishwasher or, oven, so you're not burning food, et cetera. So again, typically it's, hey, minimize pressure drop, maximize CV in a valve. I mean, the list goes on and on, but just anything that's controlling flow, whether it's airflow, gas flow, liquid flow, steam flow, phase change flow, all types of applications in that area. And then, of course, when you talk about structural designs, and this is why Ansys is so great from a multi-physics standpoint. Yeah, many of these things have, airflow and EMAG and temperature concerns. But what happens when you drop that cell phone? Is it going to break? What happens when you're driving your vehicle, on a road and you hit a pothole? Is that going to hit a natural frequency of the chassis and the thing just kind of shake like crazy? So, structural applications are all over the place. And these are some of the, core, industries where we've done a lot of work. Naturally, this is a busy slide. I apologize for it, but I want you to see from a reseller standpoint, we're very committed to ongoing learning. Getting Ansys is step one, right? Partnering with the right person, as part of that first critical step. But every day is a school day, as I like to say. Ansys, like any software company, it evolves. They come out with new features and functions and capabilities every year. So it's an ongoing learning process. So to accommodate that, we have, several scenarios outside of just a technical support, hotline, right? We have a blog, and by the way, I've put it on the screen here in case you just want to go to it. You can click, sign up, and you'll get notified whenever a new blog comes out. But we have blog posts related to all the core physics, that Ansys offers, meant to be very educational. We have a newsletter. This is just a snapshot from the one from last month. We call it the RANSIM Insider. Kind of similar to the blog. It's kind of, what's new out there, just keeping you abreast of, what's new in the Ansys world. They're constantly making acquisitions, new and emerging technologies that maybe you don't know they have that could benefit your design process. We might put some blog posts in there. We might be announcing, in this case, obviously Simulation World or an upcoming webinar we or Ansys is hosting. So a variety of different, contexts, in the newsletter there. And then something that's frankly new to us this year, a new initiative of mine, to really make sure people are properly implementing Ansys solutions to the design process is what we call the ADOPT program. ADOPT is actually an acronym. It stands for Ansys Development and Ongoing Proficiency Training. So as the name implies, it's all about helping you effectively adopt it, build a foundation, and then just continuously improving your proficiency as you go throughout the year. So this is just a snapshot of the brochure. I won't go through all the details, but essentially what we do is, when it makes business sense and this is the right training mechanism for you, we assign a dedicated engineer. We make sure, in addition to whatever license, physics-wise or number of licenses you purchase, we actually give every engineer on the team access for a quarter so that nobody's fighting over the licenses. There's plenty of bandwidth, when you're learning. We actually will get your models. We have dedicated sessions. We record them online. We have sessions every quarter thereafter where you can, bring projects that you're working on and really just get direct, mentoring and hand-holding to make sure you're getting the most out of your investment and, again, improving that proficiency. So, again, just to kind of bring this to a close here, again, really appreciate everybody's time. Some of the ways that the RANSIM approach is really empowering our businesses is twofold, right? As you might imagine, this proactive scenario here is when most companies prefer to go the purchasing the Ansys route, right? Hey, I want to mitigate having field failures. I want to mitigate, the warranty exposure we had 2 years ago, right? So they proactively buy the tool, but they need to know how to use it, right? So when somebody's proactively bringing Ansys in-house, in the manufacturing space, it's more about new designs and, how to optimize a design and mitigate risk. On the, architectural engineering construction side, which again, there's a very big simulation play there, especially in building ventilation. It's more, whether it's new, I was going to say in this scenario, it's new construction. You're building a new facility. The building owner wants to know, hey, is it going to be energy efficient? Are people, going to be warm in the winter, cool in the summer, et cetera, et cetera. And then we have the reactive scenario. As you might imagine, this is where consulting, more of a reactive approach, comes into play. Not always the case. Sometimes in the reactive scenario, people think buying the software is right for them, or maybe they start with our services. But there, in the manufacturing side, it's more about field failure. You're reacting to something tangible. The pain is real. I don't have the time to come up to speed and learn a new tool. I need the experts to be an extension of my team and just kind of do it for me to find the root cause of the field failure, fix it, and ultimately protect the organization's reputation there. And of course, on the building or AEC side, there's more retrofits. I mean, it's probably a 50-50 split for us. In other words, hey, maybe a building owner comes to you and says, hey, with the gas-fired dryers we have in this pet food manufacturing facility, people are passing out when it's 100 degrees outside. So there's OSHA concerns, legal concerns. So we can get in there and do a quick root cause analysis and show the root cause and ultimately how to fix it, so they have confidence before they implement millions of dollars in retrofits. So then lastly, again, I'm not going to read all this. Ultimately, either scenario is really empowering, design intent. That's what simulation is all about. You're going to build it and test at the end of the day. This is meant to give you insight that you don't get in a physical test. You might say, oh, but this chip is too hot, in my phone. I know I have a problem, but what's causing that problem? You don't know. It's that invisible coming to life that simulation really brings, so you can see what variables have the biggest influence on performance and ultimately how you need to redesign those variables to come up with sort of a winning solution. We have a ton of analysis expertise. I did as best I could in the short time we have here today, trying to summarize that expertise, whether it's, CFD, FEA, electromagnetics, and quite frankly, a lot of the other adjacencies that Ansys offers around, say, even Rocky, direct element modeling now, Optis and Spios on the optical side. There's no shortage of adjacency tools that we have experience with as well. But our core competency has really always been in what I call the big three: CFD, FEA, and EMAG. And ultimately, we want to preserve your design intent, by working collaboratively, whether it's as a consultant or your trusted partner as your Ansys reseller. We want to make sure through that collaboration, we understand ultimately what you're trying to achieve, so that, the insight fits within, the context you're looking for, so that you preserve whatever that design intent actually was. Lastly, at the risk of, coming across too vain here, I apologize if I am, but, just to tout some of the expertise, as long as we've been doing this, I figured for each one of the core application segments where we historically focused, I'd share sort of a splash screen of different clientele. So as you can see, we've worked with a lot of the really big players, some of which might be on this meeting here today, all the way down to some smaller mom and pop shops. But in each one of those core application segments, you can see the diversity in which we've collaborated with partners. And then lastly, I'll let you get back to other sessions in the conference. But if anything I have said today, makes sense or resonates, and you want to learn a little bit more to see if we might be a good fit, whatever capacity or shape that may take, you can reach out to me directly. Again, I run the entire business unit here at RAND Simulation. That's my phone, direct dial, and email. If you want to go more to just a generic inquiry, there's both a phone number and email there. That also goes to me, as well as others on my team. And then, if you just want to learn a bit more about RAND Simulation, you can go to our website, or you can also follow us on LinkedIn. And I have both of those listed there on the right. So again, I hope this was a valuable use of time. Enjoy the rest of the conference, and I hope to have the opportunity to chat with some of you all shortly. Thanks again.